this x into minus 1 and plus 2. So 2x squared, right? This is plus 2x minus x minus 1. Here's our plus 2, here's our minus 1. So now if you do factor by grouping, so you can group out a 2x from both of these. So I'll have 2x times x plus 1. From here I can factor out a negative 1. You have x plus 1. Now I can factor out another common, my greatest common factor is x plus 1, so I can factor that out from both of those. X plus 1, 2x minus 1. Okay. So without having to do the guess and check, there actually is a method, when you have this coefficient is not 1. Okay. So here I have x plus 1, and here I have 2x minus 1. But yeah. So from this factor, this tells me that when x is negative 1, this line is 0, or if x is a half, this line is 0. So x equal to a half or equal to 1, both of those will give me my f double prime to be 0. And again, we're not going to have any values of x that's going to make f double prime undefined. So the only two values of x that we're going to consider are when x is a half or x is 1. Okay. So again, if this is a half and this is 1, negative infinity to a half to 1, and then 1 to positive infinity. Uh-oh. Wait a second. Oh, sorry about that. Negative 1. Negative 1. So negative 1 will make that 0, and then a half will make that 0. So then here we have a negative 1, and this is a half. So again, we're going to take a look at our interval. Then we have our test value. Then we have the sign. And then our conclusion. So this tells us we need to test from negative infinity to negative 1. So we can choose something like x equals negative 2. So f double prime of negative 2 that's going to be and this isn't a 2, that's a 6. Chock full of mistakes today. Here this is a 6. So f double prime of negative 2 is going to be 6 times 2 times negative 2 minus 1 times a negative 2 plus 1. So that's going to be 6 times, you have a negative 4, minus 1 is going to be a negative 5, times negative 1. So that's going to be a positive 30. So f double prime of negative 2 is positive. So our original function should be concave up. From negative 1 to a half, x is equal to 0. We're going to choose x equal to 0. So then f double prime of 0 is going to be 6 times 2 times 0 minus 1 times 0 plus 1. That's going to be 6 times a negative 1 times 1, which is negative 6. So this tells us that f double prime of 0 is negative. So our original function should be concave down. And then for a half to infinity, x is equal to 1. So then f double prime of 1 is going to be 6 times 2 times 1 minus 1 times 1 plus 1. So then that should be 2 minus 1 is 1, so that's 6 times 1. 1 plus 1 is 2, so times 2, which is going to be 12, which is positive. So our f double prime of 1, f double prime of 1 is positive. So that tells us our original function is concave upward. Okay. So if we discuss the concavity of this graph and then find the points of inflection. So again, we looked at f double prime. We found the critical points of negative 1, or the inflection points of negative 1.5. Now, just as a side note, I know the time is kind of short, but I'm pretty close to the end. Just because you get that f double prime is either 0 or undefined does not mean that it's a point of inflection. If you look through the examples, it'll give you an example where just because f double prime is 0, it was still not a point of inflection. It was still concave. It wasn't a point of inflection. It was still the continuous concave on the other side. So once you find that critical number, or that point that you might assume to be a point of inflection, you need to still make sure that it's concave up on one side and concave down on the other. So like for instance, if you look at this negative 1, it is concave up on the left and it's concave down on the right. So that tells you that there's a point of inflection at x equals 1. And then if you look at this x equals a half, it's concave down on the left and concave up on the right. So again, x equals a half is also a point of inflection. So therefore, x equals negative 1 and x equals a half are both points of inflection.